Good morning. Today we are going to see a 4-bit down counter. Okay. In my previous lecture, we saw a 4-bit binary counter, asynchronous, and it is up counting. So we saw this. It is up counting. At the every arrival of the clock, it increases binary output by step 1. Okay, 1, then 2, 3, 4, like this. Okay. So here, so this is the up counter. Output increases from 0 to maximum, but we are going to design the down counter. Okay, so this diagram is little bit same over here. Okay, 4-bit binary down counter, same. So this is the up counter, this is same counter. We just omitted this reset pulse, because you can use here also. If you apply this, if you press this switch, all the flip flop goes into reset, or all the flip flop clears, output becomes 0 0 0 0. Same thing you can use here, but just for simplicity, just I am avoiding this. Okay, so same thing you can add here. Okay, so if you press a switch, though this high voltage is applied to this clear CR input of this all the flip flops, and all the flip flop gets cleared, and that means output becomes 0 0 0 0. Okay, but for simplicity I told that just I am going to avoid this. Okay, so see here, so this connection is little bit same. So what is the similarity between this up counter and down counter? All the JK flip flops are operated in a toggle mode. So it's similar here. JK, all the JK are connected to the plus V. Okay, high or logic level 1 state. So that when J equal to K equal to 1, all the flip flop goes into toggle condition. So this is A flip flop, B, C, and D flip flop. Okay, so this is similarity, and another similarity is we are going to observe the output from the Q output of the flip flop. So here Q output, QD, QC, QB, and QA, we are going to observe the output from the same. So this is the similarity. What is the main difference? Now the difference is we are going to apply a Q bar output to the clock of the next. Okay, now here Q bar is used as a clock of the next. Here also Q bar is used as a clock of the next. So these are not connected. Okay, so just if there is connection, we saw it by the dot. Okay, if there is connection, we saw it by the dot. So here also Q bar is used as a clock of the D flip flop. So this is only difference between the up counter and the down counter. Baki all the similarities. So remaining are the similar. So you are going to observe the output from Q, QD, QC, QB, QA. JK are connected to logic level 1. So this is similar, but difference is now we are going to, for down counting, we are going to use a Q bar output for the clock of the next flip flop. Okay, so let us see the timing diagrams for this. Okay, so we have the clock. Okay, so this is a clock we are going to apply for the first A flip flop, whose output is LSB. So here QD is most significant bit and QA is least significant bit. Okay, so all these are the negative edge triggered clock. So for the clock input, okay, mark the falling edges or negative edges. So just you have to mark the falling edges. Okay, So this is a timing diagram. Okay, consider this QA output is 0, QB output is 0, QC 0, QD also 0. So at the arrival of first clock, okay, just see here, at the arrival of first clock, first A flip-flop toggles because it is a falling edge, so QA changes the state 1. Okay, what happens as QA changes? So be careful for this connection. As QA changes 0 to 1, same time this Q bar changes 1 to 0. Okay, just you have to be careful about this change. So as clock is applied, this toggles and its output changes, QA changes from 0 to 1, same time Q bar changes 1 to 0. As this Q bar changes, so this is falling edge, okay, so Q bar changes 1 to 0, this change is applied to the clock. So this is falling edge, so because of that Q bar B flip-flop also toggles and QB changes the state. Okay, similarly as QB changes the state from low to high, same time this Q bar changes the state from high to low because both are opposite. So this is negative edge, so this negative change is applied to the C flip-flop, so it changes the state. Okay, so QC, so this JK flip-flop toggles and QC changes. As this change is positive change, Q bar is opposite, so it has a negative change. So this negative change is applied to this JK flip-flop and it also toggles. Okay, so see here, at the arrival of first clock, all the outputs of the flip-flop changes and now it becomes 1 1 1 1. Okay, at the second stage, at the second clock, what happens? So this toggles because directly it is negative. As this is negative change, okay, as this is negative change, the Q bar is positive change, so that's why it is not toggled, so it remains same, it remains same, it remains same. Okay, let us see what happens. So output becomes 1 1 1 0, that means it is equivalent to 15, it is equivalent to 14, it is decreased one step. Now again at the arrival of third clock, what happens? Output changes because every arrival of clock QA toggles because directly clock is applied to this flip-flop. Okay, so as this is positive change, that means Q bar negative change, it is applied to the clock, so because of that it changes the state. Okay, so you have to mark the positive. At the rising edge it toggles. If you see the overall overview, for the positive rising edge it toggles. Okay, there is a negative, so QB is negative change, so but Q bar is at positive change, so it remains constant. Now output becomes 1 1 0 1, it is equivalent to 8 4 2 1, 8 4 12 and 1 13, it is equal to 13, 15 14 13. Then at the arrival of fourth clock it again toggles. Okay, now if you see here, at the arrival of each falling edge, the QA toggles. Okay, at the arrival of each falling edge, QA toggles. So just you have to mark rising edge. Okay, so this is the rising edge, it toggles. So here it is the rising edge. Okay, just mark the rising edge because QA rises, Q bar falls. So just mark the rising edge directly. Okay, so this QB toggles at the rising edge. Okay, now here also mark rising edge. So this is the rising edge and this is the rising edge. Then QC toggles at this rising edge. Okay, then mark rising edge for this also. It toggles at the rising edge. So what is the difference? Here we are going to change the output for QB, QC and QD for the rising edge. But clock, this is similar. So for the falling edge of this clock, QA toggles. Okay, so here at every falling edge, QA falling edge, QB toggles, QB falling edge, QC toggles, QC falling edge, QD toggles. Okay, so here we are going to mark here falling edge, but in a down counter just you are going to mark a rising edge for QA, QB, QC and QD and mark the falling edges for the clock. Okay, because clock is directly connected here. So it is clock is connected, so we mark the falling edges on the clock and at that particular edge and the QA toggles, QA changes the set. Then for QA mark the rising edge. So here is the rising edge. So all these are the rising edges. Okay, so here also rising edge. So for the rising edge it changes, for the rising edge it toggles, for the rising edge it changes. Okay, so here no one change. So here for rising edge it changes, for rising edge it changes, for this rising edge it changes. Okay, so for this rising edge it changes, for this rising edge it changes. Okay, for this rising edge it changes, for this it changes. Okay, for this it changes. Okay, so here if we see here 1 1 1 1, now here it is 1 1 0 0. So here 1 0 1 0. Okay, so here 1 0, sorry 1 1, here is 1 1. Okay, so 1 0. So here 1 0 0 1 9. So it is 1 0 0 0. Okay, here 0 1 1 1. So up to 0 0 you have to continue, you have to make a practice for this. Up to 0 0 0 you have to continue this clock. That means up to you require. So here 4 5 6 7 8 9 10. So another 5 clocks you require. Okay, so here output is 1 1 1 1. Now truth table becomes, so your truth table input is clock and output is QD, QC, QB and QA. So at the 0 clock output is 0 0 0 0. Okay, so at the arrival of first clock output becomes 1 1 1 1. Directly it is equivalent to 15. Okay, now at the arrival of second clock it becomes 1 1 1 1 0 1 1 1 0. It is equivalent to 14. So like that it goes on decreasing. Third clock it becomes 1 1 0 1. Fourth clock it becomes 1 1 0 0. At the fifth clock it becomes 1 0 1 1. Okay, So this count you have to write this in a truth table up to 15th clock 0000. Okay, so you have to continue this down counter. Okay, so this is a down counter. So just only difference you have to understand between this up counting and down counting. What is the difference now? Let us see here. So difference is we are using here QA as the output and the clock of the next, but here we are using QA as the output and QA bar as a clock of the next. So we are using Q bar output as a clock of the next flip flop and QA as output QB, QC and QD. It is MSB and this is LSB, less significant bit. So just keep in mind that you have to mark the falling edges of the clock and just make a changes, okay, at the falling edge. Just then mark the rising edge for the output. Mark the rising edge for the output. Then it toggles at the rising edge. So here it toggles at the rising edge. Here it toggles at the rising edge of the previous. So this is the down counter. So just interesting property here, up counting and down counting both are nearly same, but there is a very little bit difference. So up counter counts up and down counter counts down. Okay, so this is the theory of the down counter. In the next lecture we are going to see the combining of this up counter and down counter. We are going to see the up counting and down counting both are combined, and just by control input just we switch up counting to down counting to up counting. If there is 0 there is up counting, if there is 1 there is down counting. Like that we are going to combine these two counters in the next lecture. So this is the down counter. You have to observe, just there are 2-3 main points just you have to keep in mind. First one is Q bar is used as a clock. So here mark the falling edge so that Q is toggles. So mark the rising edge so that you can just change at the particular output. Okay, but here rising edge, but here we are connecting Q bar, so there is a falling edge. So this falling edge is applied to the negative edge triggered clock so that it toggles. Okay, so let us stop here. So continue. So here you keep practicing of this. Okay, and this one also up to 15th clock. Okay.